Giuseppe. I'm Alex, by the way. Nice to meet you all. We have decided to split this reInvent Recap into 2 sessions. I think everything is interesting for everyone, but the first part is more focused on the machine learning operation. There is a bit of data engineering, the more hands-on part of machine learning, for builders, for data scientists, for data engineers, while the second part is more focused on artificial intelligence services. So the high-level services that are kind of like a black box that implement the magic without you having to know everything about data science and machine learning and deep learning and so on. So I think, again, both sessions are interesting for every audience, for everyone. But feel free to stay till the end or ask questions in the meantime in chat. I'll be here during Giuseppe's sessions too. So talk later.
Great, thank you, Alex. I just spent a couple of words to introduce myself. Work as a machine learning specialist at Amazon Web Services. I'm a solutions architect. So what I do is helping customers using AWS services for building their machine learning solutions that hopefully help them to, let's say, address a business challenge through machine learning. I've been working at AWS for 4.5 years so far, and in the past I have some experience. I've done a few years ago some research on machine learning, and then I've almost spent most of the time doing engineering, so software engineering. In this session today, as Alex said, we are going to explore the layer of services that we call ML services. It's a kind of platform layer that is designed for machine learning developers and data scientists to, for the hands-on people that want to build solutions, build models, train, deploy models. But maybe you don't want to take care of managing the infrastructure, of monitoring, all the things that a managed service can offer to you. We all know how much is complicated and costly doing machine learning. So we have to go through a number of stages that I assume we know pretty well, from the data labeling up to the data preparation, model training, algorithm selection, and deployment. Maybe if you're used to work more on the core data science stages, you are less involved in the deployment of models into production, but that's something that requires also a lot of time. You have to manage the infrastructure, scale it, monitor it, to detect potential drift on your data or on the model itself. It's a hard task also. Maybe one thing that sometimes we don't consider too much is all the CI/CD machine learning. If we think to software development, maybe 10 years ago was less common to think as a CI/CD first approach. But nowadays, every company of any size is kind of thinking with CI/CD in mind when software gets developed. And the trend that we are seeing for machine learning is kind of the same. So there are reports from IDC, from Gartner, that give us indication that in the next couple of years, this is one of the topics that companies are looking to address. Our goal is trying to help companies simplifying this process. And I don't know if you're familiar with Amazon Sagemaker. Amazon Sagemaker is a service, is a kind of set of services. It's more a platform actually that allows to address the end-to-end machine learning workflow, from data preparation up to model building, training, and deployment, and also continuous monitoring and improvement of the models. And these 4 stages address the kind of the needs of machine learning builders, but maybe the prepare stage is more focused on data engineers and data scientists that want to explore, prepare data sets, create analysis, understand data. The build phase is more designed to address the needs of data scientists and machine learning engineers that want to choose algorithms, build models, and test these models and so on. The training and tuning is when you actually move from the experimentation phase where you are choosing a model to the more scalable machine learning, where you need to scale on the resources, you need to train models on large data sets and so on, debug these models, and maybe do hyperparameter optimization to optimize the model. And the deploy and manage is, well, the last phase that is more designed to address the needs of machine learning engineers, but also DevOps and software engineers, because, well, it's common that sometimes you need the help of a different kind of a role in the machine learning workflow that is more focused on the operations of in machine learning. And the goal of Sagemaker is to address these 4 stages. It's covering all the steps that we have seen before in the machine learning process, but without going into the details of all these kind of stages and how Sagemaker is addressing this, I would like to rather spend a couple of words on how it works. So it's a kind of platform, it's a set of APIs that you interact with to execute the tasks in each phase. So to start the training job, to deploy a model, you have a number of APIs that you can work with via SDKs. And the nice thing that I really like of this service is its modularity. So you don't have to use it necessarily end to end. So you can pick what you need for your projects. But at the same time, you get the end-to-end integration of all these components, or all these kind of sub-services. And the user experience for Sagemaker, can be driven by any kind of development environment that you're familiar to. I don't know, you can interact with Sagemaker from PyCharm, or maybe from your own Jupyter environment. Just install the SDK and make sure that you can interact with this cloud service in terms of the credentials that you need to use to work with the service. But at the same time, we have developed an integrated IDE, an integrated environment for machine learning, but that is purpose-built for machine learning. That is Sagemaker Studio. Sagemaker Studio is a cloud-based IDE and is based on JupyterLab, plus has a few customizations that make it very useful to interact with Sagemaker components. But again, all the capabilities that you see here in the slides are kind of modular, so you can pick what you need for your projects. Let's start to look at the new things that we have announced this year at Reinvent for Sagemaker. We will start from the needs of data engineers and also data scientists to explore and prepare data sets. And I'm going to spend a couple of words on 2 services, 2 functionalities that we that are part of more of the analytics world rather than the AI and machine learning. But since, as we all know, these are stages that we can that are preliminary to building models. Just spend a couple of words. If you're familiar with Glue, Glue is a serverless service that allows you to run ETL jobs in the cloud. What we have announced this year is a graphical interface to simplify building ETL jobs with AWS Glue. So you have this nice drag and drop interface where you can combine components of your ETL flow. This produces the actual job definition that you can then run on the serverless infrastructure of Glue. This is pretty nice because, if you don't want to start from code and have a kind of code first approach, you can use the visual interface. So that's it. Another couple of words for Glue Data Brew. Glue Data Brew is addressing a kind of different need, and is visual data preparation for analytics and also for machine learning. The idea is that you can analyze interactively your a data set from Glue Data Brew. You can import it, and you have a large number, actually, more than 250 built-in transformations that allow you to automate certain tasks. So you just combine various transformations and you analyze interactively this data set. You can create the visuals, as you can see in the screenshot. And well, it's pretty nice because it gives you the chance to visually see, visually explore data. This was a capability that, again, was kind of missing in Glue, and that has been added this year. Now, just to move to the Sagemaker world, well, it's a kind of similar capability to Glue Data Brew, is Amazon Sagemaker Data Wrangler. Again, if you have used Sagemaker, you have soon realized that, I mean, there was a kind of missing capability to do that. So to interact visually with and to transform data via a visual interface. This has been added this year with this new subservice, let's say, called Data Wrangler. So the idea is that you will choose a source that can be S3, an Amazon Athena query or Redshift, and you import data into Data Wrangler, and you start to work interactively with Data Wrangler to choose a transformation, to apply the transformation, and you have kind of immediate feedback of what this transformation has done on data. So you can see interactively the results. Also, you can create analysis. So it gives you the ability to build charts and your own analysis. You can write custom code in case you need to write a custom transform. You can do it with PySpark, SQL, or Pandas code. What else? It gives you a nice capability that is named Quick Model. Well, is basically the ability to build quickly a model to look at, based on your data, choose a target variable and quickly build a model. It's nice to get initial insights of, on your data. And also this gives you an output with regards to the feature importance for, let's say, that model. And lastly, once you have finished your kind of interactive flow with the Data Wrangler, you can export your definition, your flow definition, to a job, to a Sagemaker processing job, but also to in other ways, also as a plain Python code that you can run wherever you want. But the idea is that if you export as a processing job, you will then have separate infrastructure where to run your code at scale. So maybe you can, use Data Wrangler to get insights on data, maybe on a portion of your data, on a sample of your data. And then when you need to scale and you need to transform at scale your data, you just export and you run as a separate job on dedicated infrastructure. Sagemaker processing job, for those who do Sagemaker processing, for those who do not know, it is basically service that allows you to run generic data processing job that you provide to the service via Docker containers. So most of the Sagemaker capabilities are based on Docker containers. So you define the job, you pass for execution, and we also provide a few Docker containers that are pre-built and hosted on ECR repositories that are managed by AWS, but you can also build your own container in case you want to use, let's say, your own custom container, your own set of libraries or framework for processing. And Data Wrangler is fully integrated with this subservice, this functionality of Sagemaker. So it's pretty nice. You first work visually, and then you generate a job to run at scale. Another thing is, we said, I want to explore and prepare my data set, but most of the times this data is, it's input features for my models. And you can generate the features. So given a machine learning workflow, you could generate the features each time for your model, but sometimes it makes sense to generate the features, save in a kind of central store, and then do your own experimentation starting from there. And that's the goal of having a feature store. What we have announced this year is a fully managed feature store. It's actually named Amazon Sagemaker Feature Store. The idea is that you can ingest your features into the feature store and use the feature store for training maybe multiple models from there. But also, so you have the ability to do batch and streaming ingestion into the feature store. But also, you can use the feature store at inference time. That's one of the common needs. Let's say you're doing, I don't know, a fraud detection application, and well, you need to get some features on the fly in real time when you do inference, maybe the features that are specific to the user that is executing a certain transaction, for example. Well, these features most of the time are not computed on the fly. You just need to access to them in a very fast way. And that's where the online feature store helps you. So it gives you access to sub-second latency to this data. And well, once you have your own endpoint, you can query the feature store, the online feature store, and get data. A nice thing is that this feature store has two layers, the offline layer plus the online layer. The offline layer is used for the features that you will use for training, but then you can automatically sync with the online layer so that maybe the same features can be used for inference afterwards. So, well, it's pretty good capability to decouple, let's say, the feature engineering from the actual, let's say, operations that you will run afterwards for building models, for training models. So you can kind of reuse the same features maybe for multiple models, and you don't have to redo the same thing multiple times. For sure, well, this feature store is integrated into the AWS environments in terms of security and access control. So you get VPC, private link, encryption, and so on. What else? Okay. Another common need is understanding data and detect potential problems. When we refer to when we talk about potential problems here, we are referring to detecting things like bias in your data, and bias can actually affect multiple phases of your machine learning workflow. So it's not just something that you're going to measure on your model, on the predictions of your model, but you're gonna also need to detect bias in data, for example, when you do data preparation. So pre-training bias, and then you have post-training bias, which is kind of impacted by the model behavior. And then what else? You might also need to detect kind of, how can I say, drifting bias. So what I mean is, let's say you have your model, your training data, your model is not biased, you discover that it's not biased, but then the way your model gets invoked in reality, so the data that you use to invoke your model in reality, introduce bias, so drift and introduce bias. So that's what SageMaker Clarify helps you to identify. So it allows you to detect bias during the data processing phase, so pre-training, post-training, detect bias drift, but also additionally as a capability to give you explainability, so of the model behavior by Shapley, that I guess you all know what this library does. And then it also gives you the ability to, how can I say, detect explainability drift. So basically, again, the importance of your features drift over time, is drifting over time. How it is doing this? Well, as I said, it's integrated with all the sub-services of SageMaker. So in the multiple phases, pre-training bias is detected with a number of functionalities that we have added to SageMaker Data Wrangler. The training and the kind of post-training bias can be detected by a number of functionalities that we have added. That's, how can I say, that are run after training. So you run a processing job after training to detect the post-training bias and to run the explainability, to measure the explainability. And then it is, okay, I forgot to say that it's also integrated with real-time hosting to get the feature importance of an individual prediction. And then it's also integrated with Sagemaker Model Monitor. Sagemaker Model Monitor is a service, for those who do not know, it is a service that allows you to, let's say, monitor the performance of your models when they have been deployed to production, to Sagemaker hosting. And well, we have added capabilities to monitor bias drift and explainability drift to Model Monitor. So, well, so you can think of Stagemaker Clarify as a service that is split in a number of capabilities that have been added to the various stages of the machine learning process. So that's how it works. Let's move to a demo. I want to quickly show you how Data Wrangler works. Let me bring this up. Should probably give you a sense of how is. 1 second. I just need to share different screen. Okay. Okay, I hope that you see this screen now. Well, this is Sagemaker Studio. Can someone just confirm that you see the screen?
Yeah, we can see.
Okay, great, thanks. So I was just saying, okay, this is Sagemaker Studio, the IDE that is kind of well integrated with all Sagemaker capabilities. And the example that I want to show you is, well, there is a nice new tab here that we have added that is called Components and Registries. And well, this tab here gives access to a number of, let's say, capabilities of Sagemaker projects, Data Wrangler, and so on. Since I want to show you how Data Wrangler works, we choose here Data Wrangler, and then we can choose here New Flow. And hopefully we get something. Well, I can also show an pre-existing flow. I think I have some kind of network issue. Okay. Okay. So in the meantime, it's also created a new flow. So you choose this new flow. Then you have to, as I said, for Data Wrangler, you can import data from S3 or by running an Athena query and so on. Here in the UI, you get immediately the kind of list of buckets that you can access to. This depends for sure on the execution role that is associated to the Sagemaker Studio user. And then I want to show you some, take some data. Hopefully there was kind of Abalone data set, okay, pretty well known. As you can see here, you see immediately a preview of the data. Then you can just say to Data Wrangler, import the data set. Once you import the data set, well, it creates this initial transform that is doing nothing, basically. You click on this initial transform here and you will see data and you can start adding transforms. So, well, this is the data set. Let's assume that we want to one-hot encode the sex. And somewhere we should find encode categorical. This is a transform. Okay, we don't want ordinal, but we want one-hot encoding. We choose the sex of the abalone. Okay, the output style, I want columns, and I will call it the sex encoded. And then you can do a preview, and you can see that on the fly, we get immediately get the result, interactively get the result of the encoding. And while we say, okay, please add this transform. And if you go back to the data flow, now you will see this encode categorical transform. You can also add visuals. For example, you can do this add analysis And well, you can choose to add, I don't know, a histogram on specific columns, let's say rings here. And you immediately get an histogram, and for sure you can play as you want and create multiple visuals. What I want to show quickly is the export capability. So once you pick a specific point in the in the data flow that you are building, you can do export of this specific step, and then you have multiple options. You can export to a data wrangler job. So data wrangler is integrated with the Sagemaker processing job, as I said. And this, if you choose to export to a data wrangler job, it will create kind of processing job for data wrangler automatically, and this can be run at scale. I mean, you can export to a pipeline. We will see later what is a pipeline. Is a new object that has been introduced to manage the machine learning workflow orchestration. You can export to Python code, standard Python code, or you can export to feature store. So basically, you can say that after you do all the transformations on data, I want to ingest the result into the feature store. It's pretty nice. Let's try exporting to the feature store. And what you get a notebook. I'm not choosing any kernel right now, just because we don't need to run it. But well, you get a notebook that shows you all the code to actually create the feature group that is the metadata for the feature store with all the columns and so on. And then you get, okay, these are the APIs for creating the feature group. And then there is, okay, a processing job here that is run automatically that as you can see as a processing input, basically your data and the transformer that has to be applied to the data, and as a processing output configuration, it is going to save that data, to transform the data to the feature store. That's pretty nice because again, you get all the code from Data Wrangler. So although you get this kind of interactive experience, you also have a way then to generate a notebook and to embed this into your machine learning workflow that maybe goes through all the steps and all the CI/CD that you want to define for your machine learning workflow. So the analysis moves from kind of being interactive into something that can be then orchestrated and can be run at any scale. Okay, if we go back to the presentation, how am I going with the time, Alex?
I think we are a bit behind. We can accelerate a little.
Okay, thanks. I will accelerate a little bit. So, okay, well, for the build phase, the nice thing that we have added, so for building models, nice thing that we have added this year is Jumpstart. I will be very fast on this. It's a kind of portal where you can choose more than 15 built-in solutions for common machine learning use cases. So you just pick the solution and it is deployed automatically on your account by Sagemaker Jumpstart. Also, Jumpstart is integrated with a kind of popular model zoos to allow you to kind of deploy pre-trained models quickly, and also do some kind of fine-tuning for certain specific models. Just to give a sense of what the solutions are, we have predictive maintenance, demand forecasting, fraud detection, credit risk prediction, and so on, personalized recommendation, computer vision, and so on. And well, it's nice because you just pick the solution, and then via CloudFormation, the whole architecture is created into your account. So, well, you don't have to worry about, networking security, all these topics that are pretty sensitive. Okay. Let's move to the, okay, we have moved from the build phase now to the train and tune phase. So one of the common challenges here is, well, training efficiently. And what we have added this year is a few capabilities to improve the way distributed training works. So just to clarify this point, it doesn't mean that we didn't have distributed training in Sagemaker before. It just means that we have built new mechanisms, new libraries to optimize the distributed training. So basically, we have implemented our own all reviews capability that is that allows you to do to enable data parallelism for distributed training. And then at the same time, we have a new library that allows you to do model parallelism. So to manage training those models with billions of parameters that can't fit on a specific GPU, on a single GPU memory. So well, that's it. It's very easy to enable this capabilities. If you just need to change, let's say, 10 lines of code into your code. This supports PyTorch and TensorFlow at the time being as a capability. And I just invite you to try it, because again, it's very easy to enable, and most of the times you're going to experience a pretty good performance improvement in your distributed training jobs. And what else? Okay, debugging. So how we have improved debugging potential issues while you train models. Well, last year we had announced Sagemaker Debugger. Sagemaker Debugger is kind of service that allows you to track what is happening to your training job by emitting all the tensors from the job to Amazon S3, and then on the tensors, you can run rules that can identify specific situations like, I don't know, overfitting or vanishing gradients and so on, and well, generate alerts that allow you to get evidence of that and maybe stop the training job, because you don't want to waste your resources for that. Well, this year, what we have added to the debugger is a capability that is named Sagemaker Profiler. So, well, here it's all under the same name, Sagemaker Debugger, but basically we have added this year the profiling capabilities that allow you to monitor the resource utilization while you train your models. So I make sure of things like GPU utilization, how the CPU is being utilized when you read the data, for example. And the nice thing is that besides all the visuals that you get into Sagemaker Studio, you can see for each single GPU the utilization, there are a number of charts that are automatically built for you. The nice thing is that you also get kind of suggestion of how to improve your code. So based on the profiling that has been done, and based on the profiling rules that have been run, you get kind of recommendation on how to kind of optimize your training code to better utilize the available resources. It's nice. And the nice thing again is that you don't have to write any code to enable it. It's kind of one line of code to enable it, or actually it's one line of code to disable it, because it's considered kind of automatically enabled as a capability for the training jobs. Okay, I think I already mentioned all these capabilities. Okay, as I said, one of the trends that we are seeing is how to automate the machine learning workflow, how to orchestrate, automate, and manage the CI/CD in machine learning. So this year, it's kind of big launch is Amazon Sagemaker Pipelines. Sagemaker Pipelines is CI/CD in machine learning service. Is made of 4 different capabilities. I'm not following this kind of the slides here to explain how Sagemaker Pipeline works. The first capability is you get a way to orchestrate the machine learning workflow. So basically, you can say, okay, my machine learning workflow is made of these steps, and you define the multiple steps and how to move from one step to the other. For example, there's first a processing step, then a training step, and then you want to do run evaluation. Then maybe you choose to create the model, finally to create the model object in Stagemaker. That is kind of association of the model plus the inference logic. The second capability is we have added a model registry, so to actually manage the versioning of your models and attaching metadata and metrics to your model. So it's a kind of model catalog, central model catalog. It's a pretty common capability for doing CI/CD machine learning. The third thing is we have enabled a very tight integration of Sagemaker with the CI/CD tools that are already available in the AWS, let's say, set of services for CI/CD. So code build, code pipeline, and so on are integrated with Sagemaker to do the CI/CD phases. And the fourth, we have added a lineage tracking capability. So basically, once when you use Sagemaker pipelines, you can get the whole lineage of your model from, for example, which data was used for training, how you process data, how you train data, and so on, and get a history of all the steps that were executed. And this is pretty useful for compliance reasons, for example. I want to show you quickly how to use Sagemaker pipelines. For sure, we are not going to run the workflow right now because it would take a lot of time. But I want to show you quickly Sagemaker pipelines, how to build a workflow with Sagemaker pipelines. Sorry, it's not this one. If you look at the Sagemaker examples, there's open source repository of examples, and also contains the new example for pipelines. And I've taken this standard example and also run it. And the idea is that you want to orchestrate your machine learning workflow. So you have a few parameters, input parameters. You have, in this case, it's still the Abalone dataset. You have a processing step, then a training step, then another processing step for doing model evaluation. Then based on the accuracy, you can choose to create the model or do nothing, basically. And we want, in order to make this workflow repeatable and be able, for example, to replicate the execution of this workflow in a kind of different AWS account, what you would do in the kind of, how can I say, build stage for software. So just to create a kind of comparison, here we are orchestrating the machine learning workflow, and this is the build stage for a model. So this workflow represents the build of a model, and that's why we need to orchestrate in order to replicate it in a different place. That's what we do for CI/CD, for software development. And how we do that? We define, there is this new namespace in the Sagemaker Python SDK, Sagemaker workflow, which includes the ability to create parameters, as we have seen in the picture. So you define the parameters, then you define the processing step via Sagemaker processing. This is the step where we do some kind of data preparation and feature engineering. It's code. I'm not diving deep into the code, but let's say this is just a standard processing job for Stagemaker. We create this object of the SDK that is named scikit-learn processor that is going to run that code on Stagemaker processing. And this is exactly the same object that we would use if we don't define a pipeline. So just want to clarify this point. And then you create the step. How you create the step of the workflow, you basically pass the same processor object that you were using for building for running the processing job. You pass the processor object to a processing step. You define the step. So that's the way it works. Well, there are a few steps that you have to define. Training step here. Just scroll quickly. The evaluation step here. But nice thing that I want to show you is how you define then the pipeline. You define the pipeline here. Well, it is. Okay, it's here. You define the pipeline by chaining the multiple steps that are here, and then you execute the pipeline. So you can load the definition is a JSON. It builds a JSON. So the definition of a pipeline is JSON. And then finally, you run the pipeline by doing pipeline.start here. And this executes the pipeline on the cloud, basically on Sagemaker. So the workflow is orchestrated. All the steps are executed. You get a track of that. And you also get nice visuals here. So in Sagemaker Studio, you can go here, see pipelines. You see the pipeline executions. And to give you an idea, you also have a visual of the kind of the steps. You can see the input and outputs, the logs of each step, and so on. So parameters and so on. So it's pretty nice. And the idea is that you will then execute this workflow. Once you have executed the workflow, I mean, on your account, maybe you are experimenting, you run, you build a workflow, then you commit to your repository, and then this gets executed into a separate environment for continuous integration, let's say. And well, Sagemaker Pipeline also includes the registry. The model registry is this capability here. You get the various versions of a model, and you can choose to approve a specific version for being deployed. And you also get a number of other capabilities. One that I want to highlight is the projects. That is what I said, is the link between Sagemaker and the CI/CD tools of the AWS ecosystem. Here you can see that I've linked the code commit. You create a machine learning project, and well, it associates the repositories, the pipelines, and so on. We don't have too much time, unfortunately, to dive deep on this, but I will be happy to do it at any time. I just go fast on the other topics. And well, another common requirement from our customer was how to better manage models on edge devices. And we have announced this year Edge Manager, that at the very end you can also get data from the agent to monitor the performance of your models on the edge. Well, it's a way to simplify deploying a model on edge devices at scale. And it's also integrated with Sagemaker Neo, that is the compiler for deep learning compiler to optimize models based on the target platform where we are going to deploy them. A couple of announcements also at the infrastructure level to make sure that you can get the best performance at the lowest price. In 2021, we will announce EC2 instances that are powered by Habana Gaudi processors. So the idea is that you can get 40% better price performance if you compare to the current GPU-based EC2 instances for training your models. It supports TensorFlow, PyTorch, and so on, and will be available in Stagemaker, but also on the AWS infrastructure, EC2 instances, and ECS and EKS. And another announcement this year for the same kind of context for optimization of training is AWS Trainium. Last year, we announced AWS Inferentia, that is the chip, the purpose-built chip for inference. Trainium, well, is a purpose-built chip for training, and will come in 2021. It's designed by AWS, and will also use the same Neuron SDK for that you use for inference. Well, again, this is the same picture that I have shown previously. And well, what I want to highlight here is that what you see here in the new is all the new capabilities that we discussed today about Stagemaker. Unfortunately, we had to do it very fast. And another couple of things that I want to add are how to create graph-based models that are gaining a lot of interest because, well, are very useful for specific tasks that you need to address by working on graph data, for example, recommendation, social analysis, and so on. Well, we have integrated the ability of building graph neural networks models with Amazon Neptune, basically. So you can use the DGL. AWS has contributed to this project, the Deep Graph Library. And Amazon Neptune ML is a capability of Amazon Neptune that uses this graph neural networks to actually make predictions with graph data. So it's kind of integrated with Amazon Neptune, our purpose-built managed graph database. And what else? Last thing is the ability to, if you're more a kind of database engineer, you might be interested in running models directly from Amazon Redshift. So rather than taking data out of your data warehouse and building models and then executing inferences, well, we have announced this in preview, the Amazon Redshift machine learning capabilities. So the idea is that via queries, you can build models and also run inference. So this is integrated with Amazon Sagemaker to build the models, with Autopilot actually to build the models. And what you see here in this slide is, well, how you are going to write a query to create a model. You do this create model and choose the data that you want to focus on for your model and what is the target variable for sure. And then in this way, via this function you can then execute inference. So you can run the inference either on a data set or you can run individual inferences. So in this case, we are doing kind of evaluation, running inference on a test set. And then last one is the actual inference. You do the inference via queries. So it's pretty interesting for those who do not want to, let's say, move data out of Redshift and manage the entire machine learning workflow by themselves. So this is the last thing. This is the overall picture of the machine learning stack. So in this presentation, we have covered this layer, the machine learning services, the news in the new launches in this layer, and also a few things here at the bottom layer. So the instances, Trainium, Habana Gaudi, and so on, and the improvements that we have done to the frameworks for training, for distributed training. And now I like Alex take the stage to talk about news in the upper layer, so in the AI services layer. But I don't know if we want to stop first for questions, Alex.
Yeah, we had a few questions in chat for